Welcome, everybody. Happy New Year. So glad you could join us tonight. We'll let everybody keep populating in, and we'll get started in just a minute. Tony's with us again. Yay. We're so excited to have him. So hopefully you guys are as excited as we are. Yes, thank you, Marty. Happy New Year to you too. David, David Palmer, did you have a question? Or are you just playing with the raise hand? We do that. You know, push buttons, right? You all like to push buttons. So we have so many on the trucks, right?
Absolutely. After you've driven it a few years, you don't even have to look. You already know where it's at. Just by memory.
That's awesome. All right. Let everybody continue in. Just give everybody another minute or so, and we will get started. All right. Well, welcome everyone. We are back 2022 with a new webinar. Excited to be back. I know we've had a little bit of a break, but we're getting in the gear of things. So tonight we're going to have Tony. He's going to talk to us about systems, overviews, and troubleshooting. Again, just as kind of a little reminder, if you have questions, you can put them in the Q&A box and we will get to them. If you're having issues, please use the chat box. That way I can talk to you one-on-one about issues you might be having, and we can troubleshoot those. But with that being said, we're going to turn this right over to Tony. Tony, take it away. I'm going to disappear on you.
All righty. Well, thank you, Leanne. Good afternoon, everyone. I'm Tony Martin. There we go. Maybe everyone can hear me now. Anyway, I'm Tony Martin from Elmore, Alabama, and I had a couple of influential people in my life. First off, my father was always enjoyed mechanics, and he always wanted to know how things worked as opposed to just changing parts. So in early 1960s, he started to work at Dixie Trailer and Brake Service in Montgomery. And at that time in central Alabama, a lot of people were starting to bite the bullet and go with air brake systems on their trucks. There were still a lot of trucks with hydraulic brakes. So a big thing was installing a what they called an air pack. It was a belt drive air compressor and air tanks, so you could pull a trailer that was equipped with air brakes. And he really enjoyed learning about how they worked and installing things and troubleshooting and working on them and whatever through the years. And that's the way he always enjoyed that type, the air system of the truck. And so subsequently he taught me about it quite a bit. Then I have another friend who's since passed away, who was a service manager at the local Kenworth dealer and later Peterbilt. And he was the same way as my father was. They were good friends in that respect. They each enjoyed learning how things were made and how they worked, as opposed to just changing parts. And I kind of took that from him. So at any rate, we are going to talk about air brake systems here, or the air system in general. And if I can get my screen shared here. There we go. So here we go. The first idea for using compressed air as a brake system was done by George Westinghouse, and he invented a system that they used on train cars. And he invented it in 1869 or slightly before, and it was patented then. He established the Westinghouse Air Brake Company in 1869, and in 1893, the government actually enacted the Railroad Safety Appliance Act that required his air brakes to be installed on all railroad equipment because they were very effective. Up until that time, pretty much the only way to stop a train was wait for a hill or wait for it to coast to a stop. The air brakes pretty much were very effective for stopping the heavy trains. In 1924, an Westinghouse system was fitted to an International Harvester bus. And that's the first documented use of air brakes on an automotive application. From there, they began to gain in popularity. In 1930, Bendix Brake Corporation, who was mainly a friction material manufacturer, and Westinghouse Automotive Brake Company merged to form Bendix Westinghouse. After World War II, the Bendix Westinghouse air brakes were pretty much the accepted standard for heavy trucks, trailers, buses, what have you. And they continued to evolve slightly over the years until 1975. And the Federal Highway Administration had done studies on improving the air brake system for a number of years. And the manufacturers kept putting it off as it'll be too expensive and it'll kill the industry. And finally, in 1975, it was implemented, and it had standards for stopping distance, air reservoir size, air compressor size. It mandated anti-lock brakes. It mandated a new type air system called a dual air system, which we'll talk about a little later. And it raised the price of trucks and trailers quite a bit, but everyone stomached it. And that's the reason we have the kind of brake systems that we have today, which when you really stop and think about it, being able to stop an 80,000-pound truck as quickly as we can is due to having air brakes. And so many things on trucks are air controlled now. So basic components of the air system are the compressor, which that would be the compressor, the governor, the air dryer, if you have one of those, then the lines and the tanks. And believe it or not, that's a very important part. The lines and the tanks are. Then you have the accessory valves and the components, and things like air wipers, air fifth wheel slide, interaxle lock, that type thing. And then brake valves and the components of the brakes. That'll be the relay valves, the foot valves, the brake chambers at the wheels, and so forth. So you can kind of divide the air system up into those major systems. And tonight we're going to talk about the first three. And brakes is pretty much a very large can of worms, and we need to, I'd like to spend a little more time on that. So we're going to do a subsequent webinar and cover brakes in depth a little bit later. So those are the basic air systems. The compressor, you can compare the compressor to essentially like a small engine. They have a crankshaft, they have pistons, they have a cylinder head. The only difference, instead of using gasoline or diesel fuel to generate power through the crankshaft is actually turned by the engine, and you compress air that way. The compressor gets its coolant from the engine, and it also gets an oil supply in return from the engine. And these are on most trucks, of course, nowadays, especially, they're gear driven, but in the past, belt drive was very popular, and still you see that on smaller trucks. They'll use a belt drive compressor because the engine really wasn't, smaller engines weren't really designed with air brakes in mind, so they don't have a provision for the compressor. Your compressor, since it uses since it uses coolant and it uses oil from your engine, the compressor a lot of times can be the cause of issues that normally we'd think of as being an engine problem, such as excessive oil consumption or getting oil in the coolant, or even turbo pressure loss, such as that, can all be blamed on your compressor. So your main parts, you've got your cylinder head, and there's an unloader valve here, and we're going to talk about that in depth in a few minutes. But the unloader valve is right here, and here's your piston with your connecting rod to move up and down, and much like a regular engine would operate. Compressing air, by the laws of physics, generates heat, and the more your compressor runs, the more heat that you generate. And as the air cools down, you form condensation, and thus the bleeding air tanks, whenever you get water out of your tanks, that's a product of your compressor running and generating heat and air cooling down. It's not necessarily a sign that something's wrong with your compressor. That happens. It's a product of the heat. The vast majority of air compressors are used on trucks are manufactured by Bendix, and they're a 2-cylinder design. In the early 1960s, Cummins decided they needed a lighter weight and smaller compressor. They called it a compact compressor that they came up with. And apparently it was a pretty good design because it lasted pretty much unchanged until the end of the N14 era, which was around 2000 in that neighborhood. The Cummins compressor is a single cylinder, and it has the unloaders right here in the center of the cylinder head. And here's the mount for the air governor and your unloader mechanism that goes right in the top. So same basic idea. The principles that we're going to talk about are all going to apply to both compressors, but don't let it scare you that the Cummins compressor and the Bendix compressor look absolutely nothing alike. It's still the same basic principle whenever you get down to the individual parts. Cummins does not have an external oil line because they were designed to run on their engines, and they have an internal passage to supply it with oil. They do have 2 ports on the front, which are for the coolant to come in and go out to cool the cylinder head and provide a little extended life for the compressor. The thing that controls the compressor is called a governor. And I would bet just about anyone who's ever driven a truck or worked on a truck has changed an air governor. The way it actually works is you get air from your tank, comes into the reservoir port, which is here along the bottom edge. And whenever you get to your preset amount, which is typically 120 PSI, one of these center ports, air will come out it and open the unloader valves of the compressor. And that lets it freewheel instead of actually pumping. So whenever you drop back down to 100 to 105, the air supply shuts off to the unloaders and the compressor starts pumping again. But your governor actually controls that. Same basic design. This is called a D2 Bendix. Same basic design has used for a number of years, but as you can see, there are different style caps. And if you take it apart, the piston on the inside will look the same. The compressor, the governor many times is changed And all that's wrong with it is it needs a couple of O-rings or it's just gummed up on the inside. If you're stuck on the side of the road and don't have a governor handy, you take the snap ring loose on the end, pull everything out, and you can clean it, lubricate your O-rings, put it back together, and 9 times out of 10, it will work perfect. A governor is not a complicated device, and all you have to do is take it out. Here on the end, there's a screw sticking out with a jam nut on it. You loosen this jam nut and turn the screw to set your cutoff pressure. Typically, every quarter turn is 4 PSI. So you want to adjust that to around 120 PSI for your maximum operating pressure. So the governor sits over here to the side somewhere, can be bolted to the head of the compressor, can be have a line coming to it. But under normal circumstances, the piston moves down in the compressor, pulls air through the intake by the inlet valve and into the chamber here. As it starts coming back up, the inlet valve is shut and the discharge valve opens and lets the air go out through this port and to your tank or your reservoir. When you're intaking, the discharge valve is shut. That way you're not sucking air from your tank. Whenever you're intaking, it's actually coming from the outside. And then when you're compressing, the compressed air is not going back out the intake side. So it's sort of a reed valve system or 2 check valves installed opposite directions. So your pressure goes out to the reservoir. Then when you reach your cutoff pressure, your governor sends a signal into this unloader piston. The unloader piston goes down and opens this inlet valve and leaves it in the open position. So the piston can just flow up and down and it's not actually drawing any air in. It's not actually pushing any air out. It's just running up and down. That's because your compressor turns all the time. As long as the engine's running, the compressor's turning. That prevents it from pumping air all the time. Also cuts down on the amount of heat that you're generating from the compressor because it's not pumping air. I've mentioned the unloader valves a few times, and this is a very common issue with a compressor. They're located here in the top. Depending on what kind of compressor you have, could be a plate, could be a plug. Like I say, the Cummins is mounted in the center under the governor, but it still works the same way. Here in the middle, we've got, this is what an unloader valve kit looks like. And whenever we get to the diagnosis section and we start talking about things that unloader valve trouble can cause, you can go back and reference this because these little pins with a piston on top can get sticky in their chamber. The O-ring can get cut. Various things can happen to it and cause you problems. And instead of having to replace a $1,000 or more compressor, you can put a $20 unloader valve kit in it and be back to perfect operation once again. Although it may be tempting, don't pull these out and say, oh, I'll just get some spare O-rings out of my little Harbor Freight O-ring kit. That'll probably work to cut off one time and never work again, because these are special O-rings that are on your unloader valves to handle the very high heat that is generated in the cylinder head of the engine of the compressor. So if you need to replace these, get unloader valves with the proper O-rings in it. If you go to the Bendix website or get a copy of their air brake handbook, there's a number of pictures of their different models, and you can sit down and compare how your cylinder head's made and what drive you have, and pick out the model compressor that you have, and then you'll know what unloader valve kit that you need, because each one has a slightly different valve and different diameter, because they made a number of compressors over the years with different outputs, and the output needs to be kind of related to your air usage of the truck and the size reservoir that you have. And therefore, they made a lot of different models. So you can kind of figure out what you have and you'll know what parts to get from that. If you, these springs cause the unloaders to pop back up whenever they're released. If the springs are bad, it won't pop up. There again, all that's in your unloader valve kit. So one of the most common things that you hear is this truck won't build air. The Freightliner dealer this morning to get some parts, and sure enough, there was a guy came in to get his truck worked on, and the service writer said, okay, what's the problem? Well, it won't build air. And I thought, he's fixing to spend a lot of money right now, and if he could just wait a few minutes, maybe I could save him some money. But at any rate, wasn't his money to spend. The first thing that you, or not necessarily the first thing, but one of the common things is you say, oh, I have a bad compressor. It's worn out. Well, to check that, take your discharge line off and hold an index card about 6 inches away with the engine running and see what kind of oil splatter you get on it. If it soaks the card and you can't tell that you're holding up a wire more, there's a good chance you have a worn compressor. If you just get a few little droplets, you don't have a compressor problem, you have issues. Another possibility is a restricted compressor intake. The intake for the compressor can either get its air from the intake manifold of the engine or the air cleaner of the engine, or in some cases, they have their own little filter on the compressor that I assure you has never been changed. And they get clogged up. And when they get clogged up, it doesn't have any air to bring in, and you can't compress air that you don't have. So check your intake lines and see what you actually have. The amount of oil that can backflow into that line, even if it's plumbed into the intake, will sometimes cause it to swell, and it'll restrict it that way. Number one cause, in my opinion, sticky unloader valves. And we talked about those earlier. Check them for sticking, check them for your O-rings being cut, check the springs for being bad. The governor leaking system pressure to the unloaders. If you have a cut O-ring in your air governor, the system pressure will just pass right on through and go and open the unloaders on the compressor as soon as you start building air. And a good way to check that is remove your governor or remove the line that's going to activate your unloaders on your compressor and see if there's anything coming out before you get to 120 PSI. Whenever you do get to 120, it should open, and then you get a full flow of air out of it. There should be nothing coming out until you get to 120. If you do have something coming out, replace your governor or replace the O-rings on it. Another issue for slow building air is leaks in the system. And I feel it necessary to mention this because I spent 4 hours of my life that I will never get back a few years ago with a gentleman on the phone trying to diagnose why his truck would not build air. And he was stuck on the side of the road with 60 pounds of air. And every time he thought the compressor would start pumping, he would lose his air again. And I told him what line to take loose, what wrench to use, every single thing to do. And I kept asking him, do you have any leaks? Do you have any leaks? No, nothing's leaking. After 4 hours, he happened to climb under his air dryer and said, there's air coming out of my air dryer. And I got him to bypass the air dryer, and lo and behold, he started building air and everything worked fine. But check for leaks. That even though you may not be able to hear it when you switch the truck off, you could have leaks causing your not to be able to reach 120. And a good way to do this, if you can't hear air leaks, is connect shop air to your compressor discharge line and don't even run the engine. Charge the system from your shop compressor and check for leaks that way. The compressor may not be turning. On a belt drive, that's pretty simple. The belts could be loose or worn out. But on a direct drive, like most everybody uses, Caterpillar, Detroit, Mac, have a hub that are oftentimes made out of fiber or plastic to provide a breakaway system if the compressor locks up to prevent engine damage. Those can start slipping. A Mac comes to mind. I've seen more than a few times the plastic drive hub slipping on the compressor crankshaft, and the compressor wouldn't pump but about 30 pounds of air because it was just slipping. Had to take the compressor off to figure that out, and taking the compressor off on a Mac is not particularly easy in some instances anyway, especially on a B model. The other thing to look at, if the compressor has some age to it, is carbon buildup in the head or the discharge fittings. Since you're picking up air from the truck engine in a lot of cases, you can get carbon, and it will build up in the head, and it will also build up in the fittings and restrict the size. Even though you may have a 1/2 inch pipe, have a 1/2 inch hole in the center, it may be down to only a 1/8 size hole, and you're just not getting any output. So you can take your line off and check your fittings for carbon. And if you find any carbon in your fittings, there's a good chance it's on the inside of the head inside. And according to the Federal Motor Carrier Safety Administration, to determine if your air system is working as it should, you should be able to build from 85 to 100 pounds within 25 seconds at governed engine speed. Governed engine speed is wide open as it will run. And you should be able to do that in 25 seconds. If you can't, start going over this checklist and figure out why you can't. Because as long as you can pass that, you won't have any trouble with the DOT. The issue is having too much pressure. And that's a sign that the compressor won't cut off. First thing to look at is the governor being stuck or clogged. There again, take the line loose from the governor to the compressor, or else remove it if it's a direct connection, and see if you're getting air coming out at 120 PSI. If you're not, there's an issue with your governor. The governor or the compressor plumbed incorrectly. You need to have pressure going in the supply port on the governor, and that should be coming from your first air tank. And from the discharge port on your compressor needs to go to the unloader control port. On your governor should go to the unloader control port on the compressor. Having those two lines hooked up properly, if you get them reversed, or if you have one coming from the wrong place or whatever, especially if you have an air governor, a air dryer factored in, that throws a third line in, and you can get things confused, but you need to make sure it's plumbed correctly. Another issue is plumbed correctly, but it's from the wrong tank. You need to be plumbed. Your governor needs to receive air from the first tank. And if you're actually picking up air from another tank, there's a possibility that you may have a check valve clogged and air isn't actually reaching the tank that you're picking up air out of. Thus, it needs to be from your first tank that you know is going to be receiving air from your compressor. And then, of course, our old faithful cause, the unloader O-rings could be leaking. And if they're leaking, the governor can give it all the pressure it wants to, and it will not open the inlet valve. It'll just let it keep pumping. And while we're discussing this, something very, very important to have is a pressure relief valve. Those should be installed in your first tank, the one that the governor comes out of. And honestly, it doesn't hurt to have one of these in all of your tanks, because most of the plumbing is rated at 150, 160, maybe 200 PSI. Your air valves certainly aren't rated for that much air. And before you, a simple issue like a unloader O-ring being cut or your governor being stuck, that's simple enough to fix. You don't want to run your air pressure up too high and start popping air lines and damaging air valves. So make sure you have some relief valves in your system, particularly in the first tank, and make sure they work. So I mentioned air dryer earlier. Air dryers weren't particularly popular until I'd say the 80s. You'd see them occasionally, but not on every single truck that was built. And now, of course, they're commonplace. And as we discussed in the beginning, the air coming from the compressor is hot. And as it cools down, it causes condensation and you wind up with water. So the idea of the air dryer is the air comes from your compressor to the air dryer, where it circulates through this desiccant cartridge and out to your first tank. As you can see, it says first tank. But this allows it a chance to cool down, the air to cool down and circulate through here, and you get the vast majority of the water and any other contaminants out here in your air dryer. And then you go on out to your air tank with clean air. And the way this actually operates is your governor, whenever it sends the signal to your unloaders that the system's at 120 PSI, the compressor can freewheel now, the unloaders are going to open. That line is teed, and it also comes to your air dryer to tell the air dryer it's okay to start purging the contaminants. So you've got this control line that hooks into the unloader control for your compressor, and it comes over to control the purge valve for your air dryer. Then, of course, as soon as you drop down to 100 PSI, when your compressor cuts back on, the air dryer stops discharging, stops purging. So it's kind of a neat way to keep your compressor, to keep your air dryer from bleeding your system down, constantly purging when your compressor can't keep up. So after you leave the compressor and you leave the air dryer, the next thing to think about are the tanks. And here in this particular instance, the first thing we're going to look at is over on the left side, the a discharge hose, which comes from the compressor to either your air dryer or to your first tank. And as we've stated several times, that air is very hot. So you need to have a stainless braid hose or a copper line, solid copper line, for 5 to 8 feet, depending on what size compressor you have, where your tanks are located, what kind of air usage you have. But 6 feet is a good rule of thumb. You don't need to just hook a standard rubber or nylon hose right to your air compressor, or you will risk melting it off and having serious issues. So you need to run a stainless braid or copper for the first section. The first tank that you go in is called a ping tank or a wet tank, and that's to cool the air down initially. And of course, it's going to collect the most condensation. So you would drain that tank every time you got out of the truck. You'd make sure that you drained your wet tank because it would be catching all the contaminants. Then your wet tank would feed the subsequent tanks, which were known as dry tanks. And you'd have a check valve going into each one to isolate the wet tank in the event of a hose failure or something of that nature. You keep that traps your air in your wet tanks rather than losing control of your brakes and parking brakes and what have you, and causing further issues. So A lot of the old trucks had one tank, sometimes two. Nowadays, it's pretty common to see 2 or 3, even 4 tanks. Some of the trucks that are a little bit cramped for space, you'll see the wet tank will be a large tank and it has a baffle inside. And that way you can have a small tank to serve as your wet tank, and a baffle, and the rest of it can serve as a dry tank. And the only way you really know that is you'll see a line coming out of the tank and going right back in it. And while that may not make sense, it's going around the baffle, and that's creating a wet tank area and a dry tank area within the same actual tank. And at the bottom, if you've never thought of this or never been told this, pay very close attention. Never, ever use an open flame, such as a torch or any type of sparks, around a used air tank. Your air compressor picks up its air from the intake manifold of the engine in most cases. And what happens on a cold morning whenever the truck doesn't really want to start? The driver goes around and gives it a squirt of ether in the air cleaner. It goes into the manifold, into the air compressor, and right onto the tanks. And that flammable substance is going to stay in that tank. It's going to float around, and it's not going to go out very easy. And I have seen the results of attempting to braze up a hole in an air tank, and it will explode easier than a gas tank will. So don't just, because you got a little hole or you think you want to do something with a torch to an air tank, think twice. So prior to 1975, pretty much trucks were all done kind of the same way. You had your compressor, you go to a wet tank, and you go to however many tanks that the truck needs. The first tank is the wet tank, or a ping tank, as you can see right here. I'll let you guess what this diagram pertains to. It says a ping tank is installed between the compressor and the main air tank when the main air tank is located under the rider's seat. Seat tank configuration also offers optional auxiliary air tank. So they call it a ping tank because it absorbed some of the sound of the ping of the air compressor pumping. That was the idea of it. And it also collected air at the same time. But you had your wet tank that essentially fed your dry tanks, and all of your subsequent accessories came off your dry tanks with dry air. Prior to 1975, a common thing to have was a captive air tank somewhere with a check valve, so it could receive air, but it wouldn't bleed back out. And you'd have emergency release valve on your dash to release your parking brakes. In the event of a loss of air pressure, even though you had no air pressure on your system for the brakes to work, you could release your parking brakes and get off the road with this captive air tank system. 1975, you couldn't do that anymore. We'll talk about why in just a minute. But the state of California actually required this for a while, and that's often called a California tank. If you hear an old timer mention this California tank, that's what he's talking about, the captive tank that's going to be for emergency release of your parking brakes. Notice this is a little bit more complicated than the last one. The dual air system came about in 1975 as a result of the Federal Motor Carrier Safety, or Federal Motor Vehicle Safety Standard 121. To this day, you will see reference to 121 brakes. And that refers to the changes that were mandated in how the system was actually plumbed and how it worked after 1975. You can see we have the supply tank here, which is your wet tank on the earlier systems, the single air systems. And it comes out and equally feeds a front service and a rear service tank. The front service supplied the front brakes of your tractor and every other use for air that your tractor had, aside from the rear brakes, parking brakes, and the trailer supply. The rear service was for the rear tractor brakes, the parking brakes, and then the trailer supply. So they separated it, and they used inversion valves to tie the two back together. So in the event you had a failure on one system, the other system would keep operating to help you get off the road and stop safely and such as that. And it also included anti-lock, but the dual air system, this system would remain into use today. It was altered a little bit. They removed the need for inversion valves, but the basic setup for the dual air system is still in use today. The front service feeds the bottom half of your foot valve, and the rear service feeds the top half of your foot valve. So it's completely separate there. And then it goes on to operate the brakes and other things accordingly. But on post 75 trucks, just bear in mind that you have a little more complicated air system than the dual air system. So now that we have air in the tanks, we're going to talk about some piping, the air hoses. Very first thing you need to consider, particularly with an old truck, air lines are rotten, and we want to replumb them, get all new air hose. Something to keep in mind, a lot of the older trucks are plumbed with a braided line or a rubber line, and that's sized according to the ID of the hose. The plastic that we like to replace it with is sized according to the OD of the line. So as you can see, a 1/2 inch plastic line on your left, the outside of it is actually the same size as the inside of the 1/2 inch rubber line. So anytime you're replacing a braided line with plastic, you need to go up a size. If you're replacing a 1/2 inch rubber line with plastic, you need to go to a 5/8. So you're able to keep the same size ID and the same amount of airflow. Also, while you're replacing lines, you need to make sure that your tubing has DOT stenciled on it. That signifies that it's approved for use on a highway truck. Don't opt to save a couple of dollars and get the cheaper tubing that maybe is for factory pneumatics inside a factory or something of that nature. Get something that's designed for a truck and approved for a truck, and it will have DOT stenciled on it. Should you ever get into a small accident and an investigator come out and inspect your vehicle, if he finds that you've got an airline that doesn't have DOT stenciled on it, that will come back to haunt you. So it doesn't pay to use anything except DOT approved. So the different type tubing that we've used on trucks, in the beginning, copper tubing was pretty much the accepted standard. Through the mid 60s, pretty much everything was plumbed with copper. And there again, there was also DOT copper for airlines and then for use with other things. You still see this used as the compressor discharge line. As we talked about earlier, the need for the first section of the compressor line to be something that was very heat resistant. You still see copper used for that. And believe it or not, you can still buy air brake copper and fittings many different places. Copper was prone to crack from vibration, particularly where there were clamps at. But the thing about copper, you really didn't have to worry about it rotting like you did rubber. And there's a compression type fitting that many of us are familiar with, where you have a ferrule and you have a nut, and you just run the nut on there and it squeezes the ferrule onto the line, and there you go, you're good to go. But you also see a good bit of flared copper, and that uses a flared fitting, and you use a tool that clamps the tube, and you run the die down on it and push the flare on it. That's a 45-degree flare, by the way. It pushes that on it, and then you attach it. Both are used on trucks, and just kind of a matter of personal preference. If you have a truck plumbed with copper and you want to keep it original, by all means, you can do that. And here are the two different ways that you attach it. Both of the flare tool is readily available many places because it's still used in plumbing. And here again, make sure your fittings have DOT stenciled on them, because there are some that are approved for truck use and there are many that are not. The plumbing fittings that it would be so handy to get from your hardware store and think about the money you're saving. Well, they're not approved for a truck because they don't have DOT stenciled on them. Don't decide to use those and have an issue later on. Use something that's rated for a truck. So the replacement for copper is a plastic or nylon tubing, and that's what many of us are familiar with today. That's pretty much the industry standard, what everybody uses now. It's lightweight, it's easy to work with, there's no special tools. It has an almost indefinite service life. The only issue is it is not heat resistant. So you have to kind of pay attention to where you're using this and don't get it around exhaust or close to your engine or somewhere that'll cause it to melt, because you can have an air leak in next to no time. I've seen brand new trucks delivered from the dealer that had an airline failure, and it was because they got one of the airlines was routed too close to the exhaust system. And when the exhaust system got hot with the truck under load the first time, it melted the line, and that was that. So the compression type connection on a plastic line is much the same as on the copper. You got the ferrule and the nut, but with plastic, you have to have a sleeve to support the plastic line on the inside. Sometimes you see these loose and you push it in the plastic line before you attach it. Other times it's actually in the fitting, attached in the fitting itself, and you slide the plastic line over it. When you tighten these down, there's always a question of how much should you tighten it. It's a good idea to try to leave at least one thread visible past the nut when you tighten it down. Any more than that, and you're possibly going to kink your line right at your ferrule when it collapses too much. Something that's come about in more modern times, it's also become very popular, is the push to connect type. And as you see, there's an O-ring down inside that actually does the sealing. And then there's a grab ring, which is actually a little stainless ring with teeth on it, kind of like a internal tooth lock washer, that actually holds your tubing when you push it in. Then you push this ring on the top and it releases those teeth and allows you to pull your plastic tube back out. Believe it or not, these are meant to be one-time use. If you pull one out and connect it up, don't be surprised if it leaks. It is possible to change that O-ring inside, especially on the larger fittings. You can get that O-ring fished out and get a new one in there. But just because you're buying these doesn't mean they're reusable. Just bear in mind, they're fairly expensive. Don't be surprised if you have to replace them. Road Ranger had their own idea on airlines and the splitter valves, high and low, and then on a 13-speed, their splitter knob. They used a plastic line, 1/8 tubing generally, and they have just a tapered sleeve. Their ferrule is not sort of dome shaped like on a regular airline. This is actually tapered, and it sticks in the fitting. It's a little tricky to get out, but don't get these. You can get the regular type ferrule for 1/8 tubing, but if you're working on a transmission, that won't work. You actually need the flat type, and it also uses a different nut. It uses a flat bottom nut to work with the tapered sleeve. So that's something to keep in mind when you're working on the splitter valves on a transmission, is that they intended you to use this different type connection. These they've been known as Air-Equip, Strataflex, Parker makes them now. They have all sorts of different names, but it's essentially a rubber line with a braided steel covering and then a braided cloth covering over that to protect it. Kenworth, Peterbilt, Freightliner, Mack, you see all using these, particularly during the 70s. Apparently that was when they were still cheap, because now they are no longer cheap. It was a very durable line. They're very resistant to vibration. They're resistant to heat. And they're still readily available, but the problem is they're also very expensive now. There's a couple of different type fittings. The crimp type, we're familiar with having hydraulic lines made, and you stick the hose inside, put it in a crimping tool, and it crimps the barrel down on the hose. Trucks typically used the reusable type, and that you had a removable socket that the inside had a very coarse left-hand thread that you would screw on the braided hose. Then you would use the fitting and start it inside the hose. And as you can see there in the bottom picture, number 4, whenever you stick that fitting inside the hose and engage the threads on the socket, and you run that in, and it assembles to form a completed line that won't leak, won't come apart, and is very durable. Unfortunately, it's also very expensive, as I said. There's also a type that Air-Equip, as far as I know of, invented, and later on when Parker purchased their designs, they purchased it and they still have it. That's called a push lock type. If you're needing a low cost, quick way to replace one of these braided type lines, you might want to look at a push lock. I keep an assortment of these and some tubing in my truck just in case I have a failure of one of these braided lines. All you do is cut your push lock hose to length, push it over the barbs on the fitting, and you're good to go. No clamp is required, and it's good for 250 PSI. The only problem is they're not particularly durable, and they're not particularly resistant to oil. They say they are, but oil will make them swell up eventually, and you'll have a failure of the line. But it's good for temporary to get by, or if you're on the side of the road and need to make a line quickly, push lock is a good substitute. Rubber tubing is something that's still in use today, and it's just exactly that. It's a rubber tubing with a nylon braid layer inside for support. And you often see it used from the chassis down to your brake chambers, or to the quick release valve on top of the axle, or maybe to a differential lock or something like that. They're very flexible, and they're pretty much universal. You typically see them with a 1/4 inch pipe or a 3/8 pipe end, and then 1/4 or 3/8 tubing. And with the crimp design, you can buy these from a number of manufacturers in different lengths that are already made. Or you can have them crimped yourself if you want to, but they're relatively inexpensive. And like I say, that's pretty much the only thing that there is to serve that purpose, like to run from your frame down to your chassis, is this crimp type solid rubber line. The alternative to that, there is a compression type that you can assemble yourself, and it has this funny looking little sleeve with ridges on the inside. And when you tighten the nut, it crimps that sleeve down on the rubber hose and causes it to seal on the inside on that sleeve coming out of your fitting. You see these a lot of times on the hoses running from your tractor to your trailer. And then if you have a sliding axle, sliding tandem on your trailer, you see them a lot of times from a bulkhead fitting down to the to the tandem to supply air to your tandem, your brakes. But these are easily installed in the field, and you can take these apart. And as long as you got a couple of compression sleeves, you don't need anything else. You can put a new piece of hose in, a new sleeve, tighten it up, and you're good to go. But these are, you find these on most any era truck or trailer. We're going to talk just a second about sizes and threads. Most of your air valves and various things of that nature are national pipe thread. So they have their own size. As you can see, these sizes here are pretty much to scale, and they're tapered. Pipe thread sizes are tapered. So just because you have a fitting that is 3/4 of an inch across, that doesn't mean it's a 3/4 pipe fitting. That actually means it's probably a 1/2 inch pipe fitting, because that's sized by the inside of the pipe that it's designed to go with, not by the size of the thread. So that's something to keep in mind whenever you're purchasing adapters or fittings, that pipe thread has no connection whatsoever to the actual outside diameter of your threads. When you assemble pipe threads, since they're tapered, they're designed to have some sort of seal, whether it be Teflon tape or Teflon sealant, to make sure you don't have a gall and it screws in and tightens up and you get a good seal. The braided lines that we were looking at earlier, they have a flare fitting, and here's an assortment of the different flare fittings. They're sized by a number, which generally refers to how many 1/16 the size the hose is. For instance, a 5/16 will be, they call that a number 5 hose, and so it's a 5/16. A number 10 hose, ma'am, sorry, a number 10 hose would be a 5/8, because it'd be 10/16. So trucks typically use a 45-degree flare. Whenever you go down to your local parts store and get a hydraulic hose made, they look at it and say, oh, that's a flare fitting, it's a JIC. Well, no, it's not. JIC is a 37-degree flare, and an SAE flare is 45-degree. The 45-degree is designed for air, pneumatics, such as propane, air on your truck, or whatever. And the JIC is designed for hydraulic fluid and that type thing. So in most cases, JIC and SAE are the same size. They will screw, the fittings will screw together, but you're not going to get a good seal because the actual sealing surface is a different angle. And you always want to assemble those dry. They don't use any type of sealant. You'll risk messing up the seal or contaminating the seal. It's meant to be a mechanical metallic seal by the angle of the connection. So we're going to talk about hose routing. And I'm sure everyone's familiar with zip ties, and they've seen trucks and wondered, why is that hose rubbing on that piece or whatever? And whenever you start routing hoses, there's a few things to think about. If you're going around a sharp edge, try to put a clamp as close as you can to that sharp edge, so you actually force the line to go around it and not come in contact with it. Never use a hose to support another hose. That's only going to cause issues where one rubs the other. So put some clamps on it and support it on its own. Don't rely on another hose. If you're if you're clamping your hoses that are running on a frame, if you've got one going across a cross member, clamp it close to the end, because it's going to have to turn one way or the other, and you want to be supported right at the end where it makes that turn. There's some material called windlass that slips over a flange, like a piece of metal, like a frame rail or something of that nature. to prevent abrasion on a hose. And if you can't find that, or if you've got aluminum frame and the flange is too thick or whatever, put some sort of covering over the hose to protect it where it goes over, because just because it's not touching it when you install it doesn't mean that when you get going down the highway, the wind, or if it starts raining and rain gets on it, or if it gets some grease on it and gets heavy, it's not going to come down and rub that frame or that flange sticking out and cause issues. So go ahead and put something over it to protect it to start with, because sometimes it's just inevitable that you go across a flange like that. And the other thing here is to avoid a sharp bend on a hose. Earlier, we had a chart that showed some of the recommended minimum bend radiuses for hoses. It's better if you don't even approach that minimum limit. Try to keep as much of a curl to the hose as you can, because over time that bend is going to become a kink, and try to keep a sweeping bend instead of a sharp turn. In the accessory system, the two probably most common valves for everything related to an accessory on the air system is the QR1 quick release valve. And the idea of this is you have air pressure coming in the top at this top port, and it comes out the side ports. You have two delivery ports, one supply port. As soon as your supply pressure drops the slightest amount, this diaphragm and spring inside will release, and your air will be quickly dumped from your delivery ports. Typically see these on brakes, because as soon as you lower the air pressure that you're supplying them with, you want your chambers to release so you can start moving. And quick release valves do this. You also see them on lift axles. When you need to deflate the airbags quickly, you use a quick release valve, and that's how they work. There's a diaphragm and there's a spring inside. Some of these are solid plastic. They're not meant to be serviced. Others you can take apart and lubricate, clean the corrosion out or whatever, possibly get them to work. Quick release valves are common as dirt. You probably just want to replace it. The TW series of lever control valve, you see these on the dash of trucks and every other location. It's basically, you flip it one way and it puts air out, and you flip it the other way and it cuts it off. A TW1 valve has 1/8 pipe ports. The TW2 has 1/4 inch pipe thread ports, and it's a slightly bigger body for a slightly higher volume of air. And many different circuits use the TW series valve. If you have one of these leaking the inside, if you see there's a little rubber coated disc that I've circled there in red, you take the cap nut off the bottom, and you take the pin out of the lever, pivot pin out of the lever at the top, and everything comes apart, and you can get to that little rubber disc. And a lot of times there will be a piece of trash trapped under it that you can clean out, put a little dielectric grease or something of that nature on the disc, and it'll work good as new again. Just like I say, just because it's leaking does not mean you have to replace it. A lot of times you can actually fix what you've got. It's just got a little piece of trash in there. A increasingly popular accessory is an air suspension. There are many different type air suspension valves. I picked the three most common. The one on the left is the one most of us are most familiar with. This is the old knee-way style valve, many people call it. It's been in use since the 60s. If you've ever taken one apart, where the little cover is located at here, there's a really thick gel, and there's a couple of paddles and some valve cores, like is in a valve stem of a tire, that actually regulate the air. They are not instant operating. You can move this arm several degrees either way and nothing happens. You have to hold it before it will actually start discharging air to supply the airbag and raise it up or lower it down, whichever. So the idea of this is it saves air pressure. If you're on a bumpy road, you don't have to worry about your air system bleeding off because your leveling valve is continually inflating and deflating. So these are the old reliable, most all trucks from the 70s and early 80s you saw with this type leveling valve. They use a separate dump valve and it's got a single discharge port on it as well. You'd go from that to a T to supply both sides of the truck, or you'd actually have two valves, one on the left and one on the right. The one in the center, you more often find this on trailers, modern trailers, and you do see this occasionally used on trucks as well. It's called an instant response, and that's its title is very representative of what it does. As soon as you move the linkage, it either inflates or deflates. It's instant. This is good on applications that require instant response to load change or lean. If you've got for instance, a livestock trailer and you want to, you don't want it to lean, you want to use an instant response valve, and that will counteract leaning quite a bit, because the instant that linkage starts to move, it's going to change the air pressure on that side immediately. The dump valve is actually here on the very top, made into this valve. Sometimes you can also get it without, and they also have a single discharge port, so you can use two valves, or you can actually put a T in it for either side. The one on the right, I actually like a lot. Most every air ride vehicle I have put this style valve on it, and it's called a precision response. It also is instant on inflating and deflating, and it's also very precise. If you adjust it, you can load it, you can go over terraces or through ditches or whatever you want to do and get back to a flat spot, and your airbags are going to be exactly where you set them when you were in there on the shop floor with no load at all. They have an integrated dump valve, and they also have two discharge ports that are separated, so you can run one to the left side and one to the right side and know that they're always getting the same amount of air. These will mount in exactly the same place that the CR type on the left mount as well. And like I say, that's my favorite type valve right now. I've had really good luck out of those. Even on some of the two valve systems on the old knee-way suspension on a couple of low boys I've got with separate valves, I've used these and they've worked wonderfully, much better than the CR type as far as adjustment and maintaining them and keeping the trailer setting level. Here, many trucks, particularly in the old days, had air wipers. Today, they are hated. I don't know why. Probably because they've worn out and nobody knows how to do anything with them. If your wiper is sluggish, take the motor apart and clean it. You'd be surprised what a difference that makes, cleaning the goop out that's accumulated over the past 50 years. The seal cups inside will eventually dry out, and that's the main issue you have with an air wiper motor. Aside from that, if they're still somewhat live and you can clean them up and lubricate them, 9 times out of 10, that motor will work fine. Another common issue, they have this thing called a silencer that screws in a small pipe thread on the end. The idea is so you wouldn't hear the exhaust coming out as it shifted from right to left. The silencer stopped that. What it also did was accumulated any contaminants that came out, and over 50 years, they would get clogged up. they wouldn't let air out. So when you turn your wiper on, it'll go one direction and stop because the air can't go out the exhaust. Essentially, that's blocking the exhaust port. So if you have one that'll go one way and stop, you might try taking the silencer out and see, does it work? And if it works, replace your silencer. And the other thing to do to improve your operation is on the back of your control knob or control valve, there's a needle valve with a jam nut, and you can loosen that, and that actually sets the system pressure. Running it in or out adjusts the amount of flow that's going out to your motor. And over the years, you will lose pressure, and it also takes a little more pressure to operate. So it's very common to need to give your system a little more flow on older systems. And you turn your valve wide open as you want your wiper at top speed and start moving your needle valve until you get it so it's not too erratic, but it's still working quickly, and you should be good to go then. A lot of times we have air leaks coming from these control valves on the inside of the cab. There's an O-ring just inside that housing that the shaft passes through, your control shaft passes through. And if you take it apart and take the shaft out the back, you can replace the O-ring, put it back together, and lo and behold, you no longer have an air leak. You don't have to opt for the $1,000 electric wiper system that may or may not fit. You can actually fix what you've already got. And I typically refrain from recommending a particular place to buy certain parts. However, in this case, I'm going to go ahead and say, if you have air wipers and you would like to keep them, if they're on a 1930 model truck or they're on a 1980 model truck, Rome Truck Parts in Rome, Georgia can fix you up. They're the nationwide headquarters for wiper systems on commercial trucks and industrial vehicles and such. They have new motors, rebuilt motors, control valves, arms, any type part for an air wiper system, they have it or have access to it. So if you have an air wiper system, copy down this number and this name. Whenever you have issues, they're the people to contact. And we're going to take a few minutes to talk about looking for leaks. On a pre-1975 vehicle, remember that's the single air system, in a 2-minute period, you're supposed to be able to leak 4 PSI for a single vehicle, 6 PSI for a tractor trailer. On a post-1975 vehicle, you're allowed 2 PSI per reservoir on a single vehicle and 6 PSI per reservoir on a tractor trailer. That's the primary and secondary. And I was going to mention, should have mentioned on that whenever we were talking about the dual air system, that's when you saw the 2 air gauges in your dash come into use, or 2 needles in the same valve, because that indicated your primary system and your secondary system, what the air pressure was on each. You can take a spray bottle with some soapy water or even glass cleaner if you're in a tight to find small leaks in cramped areas, for instance, under the dash, or if you've got a bunch of lines that are tied together and you hear air in that general area, you can spray your soapy water and kind of narrow down where you're getting bubbles from. It's the best thing to do if you can connect shop air or just some sort of a portable air compressor that you can move away from the truck and set your regulator to 120 PSI so you don't overcharge anything, and put air to it. And you can listen for leaks and go around the truck without fear of, or without having to listen to the engine run and deal with that interference, or fear of getting your hand or some appendage trapped in the running engine. So that's a safer way to do it. And it's also a better way to do it if you can attach shop air and charge your system. Use your senses when you're looking for a leak. Whenever you get close enough that you can taste it and Many of you probably know what I'm talking about, the taste of air. Whenever you can taste it, you know you're in the right area. You have found the offending location. Sometimes when you have a leak that your gauge is dropping, but you can't really figure out where it's going, it's a good idea to just separate your tanks, disconnect, find the line that supplies each tank and remove it and attach your shop air right there. And that way you can go by each individual tank and the system related to it and figure out which one is holding air and which one is leaking air. And that way you can, it's a little bit easier to pinpoint your problem. You can remove don't have to worry about the ones that aren't leaking. And when you are looking for a leak, that's a good idea to operate your wipers, air slide fifth wheel, interaxle lock, any accessories that you may have, because that may be the source of your leak and you're not really factoring that in. You might notice that your air pressure is dropping and not connect that it was dropping on a rainy day, and that your wipers are actually the problem. You could spend lots of time trying to find a leak, and if you didn't turn your wipers on, you'd never find it. And another thing to do is whenever your system is charged to 120 PSI, listen at your compressor. If you hear air leaking in your compressor, that could be a discharge valve or unloader valves that are leaking. And there again, you can replace those without having to replace the whole compressor, but you can check your system all you want to. And if your compressor is the cause of the leak, you'll never be able to find it. So a little bit about basic maintenance. Drain your air tanks and then drain them again. If your compressor is a belt drive, check your belts. There's nothing worse than air compressor belt breaking and being stranded on the side of the road. Check your intake filter or your plumbing that's into the engine intake for contamination. If you don't know what you have, go look, because there's a good chance you've never changed that intake filter either. Replace your air filter cartridge or whatever type filter it has on your air dryer. If you start to find water in your tanks, a little bit is to be expected, but over a couple of tablespoonfuls indicates that your filter is probably full. And check your rubber lines for dry cracks. That's something that'll sneak up on you. You might replace a line going from your tractor to your trailer, but hanging out there in the sun, it might dry rot and be ready to break in 5 years' time. You don't want that to happen on the side of the road. So check your lines and look for dry rot. When you shut your truck off and you're doing your walk around or anywhere that you can reach, feel of your relay valves, quick release valves, and see if you have air seeping out. You may not notice a drop in your air pressure on your gauge, but it's something that's going to come back to bite you later. You shouldn't have any air escaping any of your relay valves or your quick release valves whenever they're not in operation. So check that. Could be an indication that you've got an O-ring that's cut on the inside or may have something sticking, and be a good time to go ahead and clean that out before it fails on you out on the road. Keep an eye on what you drain out of your tanks. Like I say, excessive water can be caused from your compressor cycling a lot. That could be from air leaks, could be from a worn compressor. If you've got excessive oil, that could be a worn compressor, or it could also be something related to your engine that is causing too much oil to be in your compressor. But either way, if you have oil showing up in your tanks, it has to be coming from your compressor one way or the other. And whenever you've done all of that, drain your tanks again, because I can't stress that enough. Drain your tanks and keep the water and the oil and the contaminants out as best you can. And that's all I have for us tonight. In part 2, coming up in another few weeks, we're going to start looking at the brake system and we'll go over the valves that are related to the brakes, different types of brakes, wedge brakes, cam brakes, brake chambers, and how to diagnose various issues related to the brake system. So, Miss Leanne, that's all I have.
Well, that was quite a bit. There was a lot of information in there. Thank you, Tony. As always, you are a wonderful presenter and researcher, and you learn better than anybody I know. So that is always wonderful to share. Keemer, if you want to unmute yourself, you are welcome to ask a question. We will take just a couple minutes here. I know we're kind of running a little late, but we'll take a few minutes here. If anybody does have any questions, you want to put them in the question answer box. We'd love to have you. We've got lots of thanks and excellent presentations coming in.
Thank you.
Absolutely.
I appreciate that.
Again, if you missed something or you had to walk away, this will be recorded and we will get this up in the next week or so up on our ATHS website for you to peruse. Keemer? I don't know if he can. He raised his hand. We'll try. All right. Lots of very helpful things. So thank you again, Tony. It was wonderful. And
Yes,
we're looking forward to our next one. I'm going to steal this away from him. And so join us in February when we start talking about air systems and going to brakes. So I'm glad you didn't try to do it all in one. We would have been here probably for quite a while tonight.
Exactly. I like to try to be as thorough as I can and hopefully not bore everybody to death. But at any rate, I got about partway in and said, you know, it'd make a lot more sense if I do the brakes and something separate, because that's a whole different can of worms that I'd really like to cover thoroughly.
Yes, absolutely. Duncan McNaughton said, in colder climates, we use alcohol evaporator after the air dryer, but I'm aware now that alcohol is not recommended in some valves.
Right. Yes. In Alabama, we, believe it or not, we actually have that problem here. But the biggest thing with the alcohol is it's very flammable, and that's why they don't want you operating it in the system. The electronic valves are supposed to be tolerant of alcohol as far as the modern analog valves. Supposed to be tolerant, but they're going to tell you don't use it because of the flammability and the issues with that. So most everybody now says, no, don't use alcohol in the system. But unfortunately, you have to do what you have to do.
I hear you. All right. Well, thank you again. It was wonderful having everybody. And we look forward to seeing you again in February. Enjoy and always stay warm.
Thank y'all. Thank y'all for attending.
Thank you.
Leanne.